This is section 3-2, representing functions. So the first thing we're going to start off with is on page 149 of the textbook, and we're going to talk about what is a function. A function is a relation where each element of the domain, and remember the domain is all of our x values, is paired with exactly one element of the range. And so this is what a function is. So what does that actually mean? So if we have a set of ordered pairs, or if we have a table, so if we have ordered pairs, something like open 3, 7, close, and second ordered pair is 4, 9, the third is 5, 4, and the last is 6, 7. So that is a relation. So I have it written as a table. I also have them written in ordered pairs. So let's look at this. Looking at our x values. First, let's write the domain. So the domains are all of our x values. Okay, so the domain of our x values are everything in the table that's under the x column, and when written as an ordered pair is the first number of each of our ordered pairs. So we write it as D colon, open brace, 3, 4, 5, 6, close brace. That's the domain. And if you notice, there is no overlap. We don't have the same number twice. We have a 3, we have 4, we have 5, we have 6. None of these numbers are repeated, and that's important for a function. Now let's look at what the range is. The range is all of our y values. So looking at the table, and under y in that column, we have 7, 9, 4, 7. Or in the ordered pairs, the second number of each ordered pair, which is again 7, 9, 4, 7. In a function, your domain cannot have any repeat of numbers, but in our range, you can have a repeat of the number. So if we have 7, 9, 4, and 7, we have 7 overlapping. So we'd actually write the range as just R colon, open brace, 4, 7, and 9 in ascending order. And so we're just looking at what numbers are there, not looking for each individual term if a number is repeated. Okay, if on page 149, example 1 towards the bottom, we actually have a mapping here. And our x values under the mapping are -4, -1, 1, and 3. And our y values are 9, -6, and 11. Okay, so once we map these, so the -4 is being paired with the 9. So we have an arrow going from -4 to 9. And the next value under our x column is -1, and that one's paired with -6. So we have an arrow going to -6 under the y column. Under x, we next have 1, and that number is also paired with a -6. So we have an arrow going from 1 over to -6 under y. And then lastly, we have 3 under the x column with an arrow going over to 11. And this is a function. So yes, this is a function. And we can say it is a function because none of our domain or our x values are overlapping. You don't see it more than once. So that means it is a function. But our y values are overlapping because both -1 and 1 in the domain are paired with -6 in our range or our y values, and that's okay. That's legal. Okay, so that's a mapping function. On page 149, example 1b, we have a table here labeled x and y. Under the x column, we have -3, 2, 3, and 2. And under the y column, we have 6, 5, 1, and 4. So now let's look at this in terms of domain and range. So we have D colon. open brace. Now let's write all of our domain values, the whole domain, which are all of our x values. We have -3, 2, 3, and 2. And then let's look at the range. So I have R colon, open brace. Looking at our column under our y values, we have 6, 5, 1, and 4. Okay, now let's determine if this is a function. Remember, if it is a function, none of the domain will repeat itself. But the range can repeat itself. So looking at our domain, we have -3, 2, 3, and 2. So in this one, 2 is repeated. So the number 2 has more than one y value. So no, this is not a function. Not a function. And looking at our range, we don't have any repeat there because it's 6, 5, 1, and 4, but that doesn't matter. It can repeat or not repeat. So this is not a function. So what do you do if you have a set of, you have a relation, so a set of ordered pairs? This is the check your progress, page 149. So if open brace, -2, 4, you have an ordered pair of 1 and 5, an ordered pair of 3 and 6, ordered pair of 5 and 8, and an ordered pair of 7 and 10. And then close brace. Okay, so how do we know if this is a function? What should we do? Well, if we set it up into a table or a mapping, table's kind of easier, we can look at it that way. So looking at our domains, that's the first number of each of our ordered pair. We have -2. So I'm writing this in a table under our x column. -2, 1. So -2, 1, and then 3, and then 5, and then 7. And then looking at our range, we have, that's the y value, or the second number in our ordered pair, 4, 5, 6, 8, and 10. So let's first determine our domain. The domain we have, our x values, -2, so we have d colon open brace, -2, 1, 3, 5, and 7. And our range, R colon, open brace, 4, 5, 6, 8, and 10, close brace. Okay, the domain is -2, 1, 3, 5, and 7. So there is no overlap in our domain, so yes, this is a function. This is a function because there's no overlap in our domain. Okay, so we looked at determining a function using mapping, using finding the domain and range, and looking at tables. So there's another way. It's called the vertical line test. So this way, if we have a graph, we can using a vertical line, we can determine if the graph is a function or not. So if a function can only have one instance of each x value, we look at a graph, and if a vertical line is drawn and it intersects the graph in no more than one place, then it is a function. So what does this mean? So on the top of page 150, we have a graph that is a parabola. And this parabola is a U-shaped line on the graph. And if we're to draw a vertical line anywhere on this graph, we will only hit the actual line of the graph one time. And for those who are looking in a Braille book, if you put your hand on its side and lay it on the graph, moving from left to right, when you're moving across, you'll only touch the graph at one point on your hand the whole way going across. So if you put your hand on the U-shaped graph, the parabola, you'll see it only hits the graph line one time. So yes, this is a function. A parabola is a function. Moving to the next graph, where from the origin we have a line going up and to the right, and we also have a line going from the origin down and to the left. If you draw a vertical line through those two lines on the graph, you'll hit that graph in two spots, one above the x-axis and one below. So it is not a function. That is not a function. And you do the same thing if you're putting your hand on the graph and moving it across. You'll feel it hit your hand in more than one spot. So that is not a function. The last one on page 150 is two lines, one above the x-axis and one below. But again, even though these lines are not connected to each other, when you're moving across the graph from left to right, you'll only hit the graph one time. The same thing with your hand. So that is also a function. And that's what we call the vertical line test.